Hey there, folks. Let's talk about message design patterns. Later, when we look at some code, we're going to be looking at it through RabbitMQ is what we're going to be using, but all of the topics and concepts we're going to discuss can be used in Kafka or Google's PubSub, whatever AWS has, whatever equivalent they have, and I'm sure any sort of thing we talk about could be created in raw code in whatever language we'd like. So at its simplest, we have a publisher that sends a message to a queue, waiting for consumers to collect them if available. Now this can be done from a single application into the external queue, back consuming by that same application, but more often than not, we see an application sending things into a queue for different applications to consume. So we can be like, same Java to Java, Java to Python, JavaScript to, you get the idea. Also, because it's sending it into the queue, and this can loiter here as long as necessary, it is, a form of asynchronous communication. So slightly more complicated, we have the many competing workers implementation. So in this one, we have one publisher, one single that sends message to a single queue, and then we have two multiple consumers all grabbing for that one. So only one of these will be able to grab the message. Only one of them will get the message, and we'll actually see an implementation of that later. Even more complicated, we have the publish and subscribe implementation. So there's this right here, this is an exchange. I'll talk about that in a moment. But so we have one publisher that publishes messages to two different queues, and each consumer has its own queue, or perhaps each group of consumers. If this type of consumer is a different program from this, we might be able to have many greedy or many competing workers within, nested within this architecture. But at its simplest, one publisher and then everybody, both of these would get the same message. They would both get a message, whereas before, only one of them would pick up the message. We can make this as complicated as we want with, I believe, all of them. I know for RabbitMQ specifically, this is how they do it. You see these different dots. This is something that's called a routing key, and I'll talk about that in a moment. But we can decide through the exchange just by giving it a different routing key which queue it should enter, and thus which type of device or which region or whichever consumer we want to get it. But we can combine these in a whole different bunch of different ways to get there's dozens more design patterns for messaging that were far too complex for me to go into right now. But how? There's three main ingredients. We have exchanges, we have route keys, as I mentioned before, and then we have queues. So we combine these in many different various ways in order to make the different types of messaging patterns. So here we would have a publisher, we'd have an exchange, and then we'd have a single routing key that would go to a single queue, and then the consumer. So it's a one-to-one. Where here we would have the publisher, a single exchange with a single routing key, single queue, but then multiple consumers. In this one, we deviate though. Much like in this example, you can see this is a slightly more well drawn out. We have this single exchange, but then that exchange has binded different routing keys, so we have to bind them all. So it's the way we bind it is it determines how the overall structure looks.